You know, when you think about our solar system, you probably picture a pretty calm, stable place. But if you look way out at its outermost edge, there's this giant halo called the Oort cloud, and it tells a totally different story. It's not just some quiet collection of comets. It's a survivor. And its story, well, it's a cosmic detective mystery. Okay, let's get into it. To really get this story, we've got to travel way, way out. I'm talking to the very edge of the sun's gravitational pull, trillions of kilometers away. This is a place we've never actually seen with a telescope, but we can definitely feel its presence. And that place is the Oort cloud. This idea came from an astronomer named Jan Oort way back in 1950. He imagined this gigantic spherical bubble surrounding us, made of trillions of icy bodies. And every now and then, one of them gets a little nudge, falls inward, and becomes one of those spectacular long-period comets we see. A visitor from the oldest, most distant part of our home system. But right away, you hit a massive problem. This cloud is unbelievably fragile. I mean, the comets out there are just barely hanging on to the sun's gravity. So how in the world did it survive the absolute chaos of the solar system's birth? That's the paradox, and that's what we're going to figure out. So the first clue is all about where the sun was born. See, it wasn't born in the quiet cosmic neighborhood we live in today. Not at all. It was born in a bustling, dangerous, and incredibly crowded city of stars. And this really paints the picture, doesn't it? Today, the sun is pretty much on its own. Things are relatively calm, but back at its birth, it was jammed into a dense star cluster. Think of it like a cosmic demolition derby, with stars constantly whizzing past each other. And to put a number on that chaos, researchers think the density was something like 14 solar masses per cubic parsec. Now, to give you an idea of just how crowded that is, it's like taking thousands of stars and cramming them into a space where today you'd probably only find one. In an environment like that, close flybys with other stars weren't just a possibility, they were guaranteed. And for any baby Oort cloud, those flybys would have been devastating. As a few researchers put it pretty bluntly, any early Oort cloud would have been ripped to shreds. The gravity from all those passing stars would have just stolen its comets, basically flinging them out into deep space. So if the Oort cloud couldn't have been there from the beginning, then how does it exist at all? Well, this is where the story takes a fascinating turn. It turns out the key to survival wasn't about being strong. It was all about perfect timing. Let's just look at the numbers from the simulations. If the Oort cloud tried to form right at the very beginning, when that star cluster was at its most crowded and violent, well, the odds were terrible. A whopping 88% of these potential clouds would have been torn apart. Only a tiny 12% would have made it. But look what happens if the cloud forms much later, say 250 million years after the cluster's birth. By then, the whole cluster has started to spread out and thin. And bam, the survival rate nearly triples to 32%. This makes one thing incredibly clear. The later it formed, the better its chances. And that just lays out the solution perfectly. The Oort cloud isn't some ancient artifact from day one. Nope, it's a refugee. It could only start coming together after our sun got kicked out of its chaotic birthplace, probably sometime between 20 and 50 million years after it was born. Only then, in the safety of empty space, could it start to build. Okay, so the sun makes its great escape. But then what? How do you build a giant sphere of comets from scratch when you're out in the middle of nowhere? Well, it turns out our solar system has this incredible internal engine for doing exactly that. It's like a cosmic conveyor belt. And here's how that conveyor belt works. It all starts when a little icy object gets a gravitational nudge from an ice giant like Uranus or Neptune. That little kick sends it on a huge, stretched-out orbit. Then, once it gets really far from the sun, the gentle but constant pull of the entire Milky Way galaxy, what we call the galactic tide, starts to take over. And that tide slowly lifts the comet's orbit up and away until it's settled into a nice, stable, nearly circular path, way out in the deep freeze. But here's the thing. Which planet does the nudging is absolutely crucial. You've got Jupiter and Saturn, the gas giants. They're just too powerful. They kick these comets so hard that they fly right out of the solar system forever. You could always call them polluters. But then you have Uranus and Neptune, the ice giants. They're the master builders. Their gravitational kicks are much gentler, just perfect for placing comets onto that conveyor belt to their final home in the cloud. So when you put this all together, the Oort cloud is so much more than just a reservoir for comets. This whole dramatic story of destruction, of escape, and then of careful rebuilding, it makes it something way more profound. It's a fossil preserving the incredible story of our solar system's birth. And here's the absolute best part. That fossil, it isn't entirely our own. Some amazing research suggests that while maybe 70% of the comets in the Oort cloud are native, meaning they were born right here with us, a staggering 30% might have been captured from other stars during those close encounters back in the birth cluster. That's right, part of our Oort cloud is alien. So let's just recap what this incredible object is telling us. Its very existence proves the sun was born in a crowd. Its survival is a story of a great escape, of perfect timing. Its structure is a testament to the gentle work of the ice giants and the galaxy itself. And its composition? Well, it tells us it contains pieces of other solar systems, from our sun's long-lost siblings. And that completely changes how you think about the Oort cloud, right? It's not just some distant, cold curiosity anymore. It's one of the most exciting frontiers we have. It means that to study the building blocks of other star systems, we might not have to travel light years away. We might just need to look a little closer at the ancient, icy visitors in our very own backyard.